Hey kids, Flexing Teacher Weber here. In our my last video where we started investigating right triangles, we started using right triangles to count the area of squares. Now what we're going to do in this activity is we're going to build on that same idea. We're going to be using right triangles to calculate the area of squares and then hopefully discovering something big. Now, what I've got on this page here is a bunch of very famous diagrams. And you can see in diagram 1 here, you've got a right triangle, and then connected to that right triangle on its vertical leg, you've got a square. On its horizontal leg, you've got a square. And then opposite the hypotenuse, you've got another square connected. And we've got 5 diagrams like that. So what I had the kids do is I had them make this chart where what we're going to do is there are 5 triangles and we're going to calculate the area of the square on the vertical leg, the area of the square on the horizontal leg, the area of the square on the hypotenuse, and hopefully discover some sort of important idea in math. So if you look at diagram 1, the area of the square on the vertical leg is pretty easy. It's 3, 6, 9. So that square has area 9. On the horizontal leg, it's 4, 8, 12, 16. So on the horizontal leg, it's area 16. Now, the area of the square on the hypotenuse is where we have to use some of our tricks from last time. So we've got this square on the hypotenuse divided into 4 right triangles plus this little guy in the middle. What I'm going to do is I'm going to take one of these right triangles and I'm going to connect it to the hypotenuse of another. And then you get 2 of these right triangles will be 4, 8, 12. So 2 of those will be 12. The other 2 will be 12. Plus you have the one in the middle. So that adds up to 25. So the area of the square on the hypotenuse is 25. Now let's do the same thing in number 2. Number 2, the area of the square on my vertical leg, this one here, is 5, 10, 15, 20, 25. So the vertical leg square is 25. All right. The horizontal leg square is 3, 6, 9. So this one is 9. And then we got to use our special counting technique, wrong way, to get the area of the square and the hypotenuse. So remember, I'm going to take one of these right triangles, connect it to the hypotenuse of another, and you'll get 2 of those right triangles, but you won't have any half mini squares. I'm going to count 5, 10, 15. So 2 of these right triangles make 15. These 2 make 15, plus the 4 in the middle. I'm going to say the area of the square and the hypotenuse is 34. Number 3, vertical leg square, 4, 8, 12, 16. Horizontal leg square, 2, 4. Okay, now the square on the hypotenuse. This one right here. Well, remember, right triangle, right triangle, right triangle, right triangle. I'm going to take one of the right triangles, connect it to the hypotenuse, so we can just count the squares in there, and we'll have 2 of the right triangles that make up that square. So I'll count 4, 8. So 2 of the right triangles in the big square make 8. The other 2 make 8, plus the 4 in the middle. So the area of the square on the hypotenuse is 20. Wonder if you're seeing a pattern in any of these numbers yet. There's a really famous pattern there. Let's look at the last two triangles. Number 4. So area of square on vertical leg is 4. Area of square on horizontal leg right here is 9. And the area of the square on the hypotenuse, I'm going to do my right triangle trick. So 2 of the right triangles in that big square are 6. The other 2 are 6. Plus 1 in the middle makes 13 for the area of the square on the hypotenuse. And the last one, number 5. Okay, the area of the square on the horizontal and vertical is the same. It's both 4. So we will say 4 and 4. And then the area of the square on the hypotenuse, this one right here. Well, I'm going to say 2 of the right triangles that make up that square are 4. The other 2 are 4, which makes the area of the square on the hypotenuse 8. Now check this out. Do you see a pattern in these numbers? Hopefully you see this. 9 plus 6 equals 15. 25 plus 9 equals 34. 16 plus 4 equals 20. 4 plus 9 equals 13. 4 plus 4 equals 8. What you get here is that if you take the square on the vertical and the square on the horizontal, add them up, you will get the square of the hypotenuse. The sum of the squares of the legs equals the square of the hypotenuse. This is a very famous math equation. So in a right triangle, the sum of the squares of the legs equals the square on the hypotenuse. This is a very famous math equation. It's called the Pythagorean theorem, and we're going to study that in more detail. We're going to learn where it comes from, what it's used for, and how to make calculations with it. So in a right triangle, the sum of the squares on the legs equals the squares on the equals the square on the hypotenuse, and you can see that in all of these. If you take the square on this leg plus the square on this leg, it equals the square on the hypotenuse. Always for right triangles, and that only applies for right triangles. So this guy here, pretty big deal in mathematics, and we're going to be learning more about this Pythagorean theorem in the days to come. Hope that sort of makes sense. That's all for now. Flexing Teacher Weber, out.